We're specifically going to look at the ethanoic acid titration. So the learning intention is to determine the concentration of ethanoic acid in vinegar, and we'll do this through calculation, and we'll also look at some sample questions that appear frequently in exams. So to start with, it's important to know what is in your burette, your pipette and conical, and what your indicator and endpoint colour is. So in your burette, you're going to have ethanoic acid, and it's going to be of unknown concentration. So when you're doing a calculation on the ethanoic acid experiment, you're going to be figuring out the concentration of the ethanoic acid itself. In your pipette and conical, you have sodium hydroxide, and this is of known concentration, and we usually use 25 centimetres cubed of it. The indicator used in this experiment is phenolphthalein, and the colour change is from pink to colourless. It's very important to remember your dilution factor in this experiment, as it may be hidden within the question. So here's some sample questions that appear quite frequently when the ethanoic acid titration comes up. And the first one says, why is it necessary to dilute the ethanoic acid? And it's important to dilute the ethanoic acid to avoid having to use a large volume of your base or a large volume of sodium hydroxide. It may also be asked, why is sodium hydroxide not placed in the burette? And that's to prevent it from clogging. Another question they may ask is to describe how you would measure 25 centimetres cubed of vinegar and dilute it using deionized water to exactly 250 centimetres cubed. So this question here is testing your knowledge on dilutions. The first thing you need to see with this question is that there's two parts. It asks you how do you measure and how do you dilute. So you do need to split your answer into two parts to make sure that you are hitting all of the necessary answers. So if we do measure first, the first step would be to use a pipette that has previously been rinsed with deionized water and with the solution it's to contain, which is the vinegar. The second step would be to fill the pipette and read from the bottom of the meniscus, so making sure that it is in line with the graduation mark. The next step would be to drain from the pipette into your volumetric flask, to tip the base of the pipette against the wall of the flask and do not blow out the last drop, as the pipette is calibrated for this. And we discussed all of these processes in our earlier video on titration technique. Next, we're going to look at the steps in diluting. So you need to ensure that your volumetric flask has been rinsed with deionized water only. You do not rinse it with the vinegar, as that would affect the concentration. So then you drain into the volumetric flask, as we said previously in measure. And what you do is you fill the volumetric flask with deionized water until the bottom of the meniscus is in line with the graduation mark, and you add the last few drops of deionized water. It's best to add them using a dropper for accuracy. You then stopper and invert 20 times. So that's a very common question that would come up on these kind of ethanoic acid titration questions, as dilutions are a particular focus in this experiment. So let's look at a sample calculation, and this came from 2016 question 1. I've just summarised the necessary information needed to do the calculation. So it says 25 centimetres cubed of vinegar was diluted to 250 centimetres cubed using deionized water. This diluted solution was titrated against 25 centimetre cubed portions of a standard solution of sodium hydroxide, which contained 1.2 grams in 500 centimetres cubed. The average titration figure was 18.5 centimetres cubed. The equation for the titration reaction is as follows, and it asks you to calculate the concentration of the ethanoic acid in the diluted solution in moles per litre, in the original solution in moles per litre, and in percentage weight per volume. So we're going to do this by first principles. So at this point here, I just want to point out the 25 centimetres cubed of vinegar was diluted to 250 centimetres cubed using deionized water. That's only important for part B. We're going to focus on part A to start with. So it's important to remember again that you've got your 3 steps in first principles. So the first step is to find the number of moles of your standard solution that you have in your titration volume. Now, we don't have moles at the minute, we only have it in grams. We're told that we have 1.2 grams in 500 centimetres cubed. So that would mean that I would have 2.4 grams in 1 litre. Now, we know to go from grams to moles, you have to divide by your molecular mass. So the molecular mass of sodium hydroxide is equal to 40. So to find out the molarity of my sodium hydroxide solution, I must do the 2.4 and I must divide it by 40. And that gives me 0.06 moles. Now that's moles per litre. In step 1, you're asked to find moles in the volume that you use in the titration, which is 25 centimetres cubed. So we need to use the formula molarity multiplied by titration volume divided by 1000. So my molarity is 0.06. You divide that by the 1000 and we're going to multiply it by 25 because that's how much centimetres cubed. So step 2 involves using the balanced equation. So for step 2, we see that I have CH3COOH plus NaOH. And I know that that is a 1:1 ratio. However, I don't have 1 moles of my sodium hydroxide. I have 0.0015 moles. So because it's a 1:1 ratio, the concentration will be the same. So I have 0.0015 moles of ethanoic acid, but that's in 18.75 centimetres cubed because that's the average volume that we use of our ethanoic acid as stated here in our question. So just move step 2 up there into the corner to make room for step 3. And step 3 basically asks us to find the concentration of our ethanoic acid in moles per litre. So we know that we have 0.0015 moles, and that's in 18.75 centimetres cubed. So we can use the formula from the 3rd step of our first principles, which is moles divided by the titration volume multiplied by 1000. So we know that the number of moles that we have is 0.0015. We divide that by 18.75 and that's multiplied by 1000. We know to divide by the 18.75 because that's our titration volume, as you can see up here. And when you put that into the calculator, you get a value of 0.08 moles per litre. Now, at this point, if we go back to the question, we can see that we're looking for the concentration of the diluted solution per centimetre cubed, not per litre. So for part A, what you would have to do, an extra step that you would have to take in order to be able to answer part A, would be to do your 0.08 and divide that by 1000, and that will give you 0.00008 moles per centimetre cubed in your diluted solution. So part B asks you to find the concentration of the original solution in moles per litre. So you have moles per centimetre cubed from part A, so bring that back to moles per litre, so do the 0.00008 by 1000, and that gets you the 0.08 moles per litre. That's of the diluted solution, but the question here says there's 25 centimetres cubed diluted to 250. So 25 centimetres cubed diluted to 250 would be a 1:10 ratio for me, so it's diluted by a factor of 10. So you need to multiply by 10 to find the concentration of your original solution, and that gets you 0.8 moles per litre. So for part C, it asks you to calculate the concentration in percentage weight per volume, and we know the percentage weight per volume means grams per 100 centimetres cubed. Now, we have 0.8 moles per litre. So to go from moles to grams, you need to multiply by the molecular mass. So we need to multiply by the molecular mass of our ethanoic acid, which is CH3COOH. And we know that the molecular mass of the ethanoic acid is 60. So if we multiply by 60, we get 48 grams per litre. But I don't want grams per litre, I want grams per 100 centimetres cubed. So I need to go and I need to divide that by 10. And the reason I'm dividing by 10 is there's 10 100s in 1,000 centimetres cubed, which is a litre. So that gives me 4. On ethanoic acid. So that's it for this video. Have a read over the learning intention